Greetings, class. Today we're going to start a new unit on complex numbers. Have you guys studied these before? Okay, guys. I see we still have some communication problems. Come on, over. First, we got Infantes. Okay. Seeing as none of you know what this means, perhaps you should do a project on its origins.
Guys, get the out of here now!
Hello guys, let me introduce myself. I'm Huron. As you see, I'm in Alexandria, a port city in the Mediterranean, near the Nile Delta. I am, however, from Greece. I have done several contributions to math, such as equation for finding the area of a triangle for its perimeter. Furthermore, one day, I came across complex numbers. I reflect my conclusions in a book. Not only was I am mathematician, also an inventor. One of the things I invented was a precursor to the steam engine.
Huron was born in Alexandria, which was later known for its port and library. He was born in the year 60 AD. At that time, Egypt was governed by pharaohs. Huron was the first man which casually came across complex numbers. Huron came across complex numbers when trying to solve for the volume of complex 3D shapes. The equation, or the square root that he found, was 81 minus 144. He reflected such a finding in his book Istiometrica. In such a book, there was a problem in transcription because, as we know, during that time, most authors did not write their own books. They had someone else which wrote the books for them. Maybe this person didn't know what Huron really meant and changed the order of the numbers. Therefore, it is unknown if Huron found it exactly or if there was an error in transcription and it seems as if he found it. But certainly he is the first one which might have come across these complex numbers. Huron's life was not only limited to the realm of mathematics, because in mathematics he also tried to find the area of a triangle as a function of the perimeter. He also, for example, found a way to make fountains, siphons, which now power our so-called water closets, and also a precursor of what would now be the steam engine, which drove the trains before. All this occurred thanks to the help of a Greek man in the year 60 AD.
Hello, I'm Girolamo Cardano, a Roman scientist from the 16th century. I was the first in solving the pressed cubics, thanks to a formula a good friend gave me. Finally, I published all my studies in maths in one book, the Ars Magna, in 1545.
Cardano found his formula in a very singular way. At first, a teacher called Pharaoh had the formula because he had found it. He passed it on to a disciple called Fiore, which later had an encounter, a mathematical duel, it could be called, against Tartaglia, which was called so because he stammered. He, Tartaglia, found the formula again on his own and won the duel. He, in confidence and under agreement of secrecy, gave the formula to Cardano. Later, Cardano, to be able to publish a work on this equation, had to find the proof. However, he did not have it. Therefore, he went back to the teacher, Pharaoh, which was already dead, looked amongst his papers, and found the proof. Later, Cardano would publish in his work Ars Magna, the Great Art, he would publish his conclusions. One of such conclusions would be the Cardan formula. The Cardan formula is only valid for depressed cubics. The formula for depressed cubics can be obtained substituting a value into the default formula for cubics. Cardan's approach to complex numbers was very singular. As for him, these were only tools for obtaining roots of cubics, not a thing of in themselves.
Mathematician, philosopher, and warrior are just some of the traits I had. Hello, I'm René Descartes. I was born in the year 1596. I attended school with the Jesuits, participated in sieges, and created Cartesian geometry. I will be remembered for my phrase cogito ergo sum. This will be one of the tools I will use to find imaginary quantities. I've published several works, some of these on mathematics, but I'm mostly known for my philosophy.
Descartes was born in the year 1596. He was a philosopher and also developed Cartesian geometry. He discovered that imaginary quantities, his name for complex numbers, would have one root for each degree of the equation. However, these roots did not have to correspond to any real quantity. Later on, to develop the name of complex numbers, Gauss, another mathematician of a later time, would come up with the rules of operations of complex numbers, the notation of complex numbers, and he would come up with all these using a geometric approach, much like Descartes. Descartes associated complex numbers with geometric impossibilities. Some of these were obtained through his Cartesian planes. He tried to resolve these equations using such means. Later on, in the year 1637, Descartes wrote a long treatise on these things that he had been discovering through the use of geometry. This treatise had 3 appendices and was very long. Descartes died after having lived a very long life in which he was involved in war. He died teaching the Queen Christina of Sweden. Since he was giving her classes at 5 a.m., he caught a cold and died. Good morning, class. So, I don't know what happened after last week's incident. I don't know, did you do the project? Did you understand something? How did it go?
Yes, we fully understand the concept now.
Move over to the later. Okay, that's great. That's what I wanted to hear. Thanks. Good job. Guys, now it's your turn to answer 2 questions. So here they go. 1. What was the role of Hieron of Alexandria in finding complex numbers? And 2. What work did Cardano write? Now it's your turn.
sido este, por si acaso. ¿No?
Sigue grabando, sigue grabando.
Sí, sigue grabando.
Sí, sigue grabando.
Tú, es que tenéis que aguantar 40 segundos, ¿vale?
¿Cuánto lleva?
Lleváis 5. Lleváis 5.
No, God! No, God, please, no! No!
I'm Girolamo Cardano, a Roman scientist from the 16th century. I was the first in solving the pressed cubics.